What's holding you back from starting or growing your business into what it can be? Well, if you're watching this, it's not a lack of information. What you're about to see is all you need to get motivated to start making waves. Do It For a Living details the journey of today's true players in their own words. Find out how they broke out so you can too. The time is now. The time is always now. Welcome back to another episode of the Do It For a Living podcast. I'm Kevin Dubois, and I've got with me Richard again.
Hello.
Richard is going to give us part two of our manufacturing kind of deep dive, and really more or less like learning different topics in manufacturing. And in the last episode, we covered several very good topics, and this one I think we got a couple more, that some of them that people have never heard of, and some of them that I think people should definitely be using. So Richard, how you doing today?
I'm doing well. How are you doing?
I'm doing good. So let's go ahead and get started. We left off on the last one talking about, I believe, standard operating procedures, and we stopped before we got to what is called Pokeyoke. Mm-hmm. Tell me what Pokeyoke is.
So Pokeyoke is a manufacturing term. It is, the definition of it basically is you can only assemble something in one fashion. So this applies mostly to our listeners that are manufacturing some sort of item or something like that. If you're working on like a service type of stuff, the engineer or the car manufacturer or whatever business that you're in, a lot of it's already been Pokeyoked. Okay. So basically it means that when you're installing a component, like the end user is installing the component, it can only fit one way. Okay. So like a good example is our flex fuel kit. When we designed our bracket that mounts to the engine for the Evo 8.9, you look at the bracket, it's very intuitive. There's only one way it can be bolted together. It's not symmetrical. The bolt pattern is different in every direction. So whenever you assemble it, it clicks in one way. You put in the sensor, you mount it on the car. There's only one bolt that holds it in the top, and you're in business. So some other good examples of that are like we also make a surge tank. A surge tank only can be assembled in one way. There are some plugs and some hoses and a pump and some bosses that mount the pump, things like that. And when you open it from the box, it's like, okay, it's very easy. There's just a couple of bolts. Here's all the items, and it just fits.
Okay, so here's a goofy one, right? So brake discs are Pokeyoke. They can only go on one way, right? Mm-hmm. But a brake pad can be installed backwards.
Right.
Right? So you see funny stories of people doing that don't know what they're doing, install the pads backwards, right? So that there's no like error proofing to keep that reversible.
Right. But like on discs, you can do right to left and left to right. Okay. Depending if they're slotted, drilled, whatever.
Sure. Okay.
And so in that way, the way they get around it is there's some sort of stamp or some sort of label that says this is right hand or this rotates in this way, counterclockwise or clockwise rotation, depending on what the component is. But it's physically labeled like, when we put a set of cams in, this is the exhaust and this is the intake because it's stamped on there, and there's no way you can flip it over, get it this way. Intake and exhaust, so it only goes in one way.
Okay. And so tires, another example would be they would be stamped.
Yes.
If they can go one direction, or if they're not directional or omnidirectional.
Inside, outside,
sure,
whatever.
Okay.
Yes.
Interesting. Okay, so what's the difference between like error proofing, which is what this is, right? It's preventing people from making errors on installing, and like quality inspections. Like how does that differ?
Well, Pokeyoke starts at the engineer or whoever's designing the component. Okay. So it's inherent in the design. Okay. So error proofing is typically what you would do when you're at your service bay or you're doing that activity, whatever it is. You're in your engine room and you're assembling the components. So like for us, error proofing would be the thing we never did the way I was talked about was we had this 3D printed holder that had all the valves in it.
Oh, yeah.
And it's in order.
Yep.
And so you take the valve out and you put it in intake 1, intake 2, intake 3. And you put the buckets in there the same way. So it's intake 1, intake 2, intake 3. And so you're error proofing it because as you're taking it apart, you're putting it in a labeled bin or a labeled type of organization. So you're technically error proofing it at that point because it's not 100% error proof because you could still drop it on the floor and all the pieces go everywhere and then all your errors are everywhere because you don't know what went where. Right. But as long as it's in this rack or this organized piece, then you can you keep it organized and keep it error proofed.
Okay. So in this example you're giving is perfect because I do this basically every time we take apart an Evo 10 head because the buckets are all individually sized and specific to a valve.
Right.
So when I take them apart, I take the bucket off. I record the size in a spreadsheet, and I use the spreadsheet to know how to put them back. But we just dump them all in a bin, right? So they're all mixed up in the bin. So if you don't have the spreadsheet and you're putting them back from the bin, you literally have to put the whole thing together, measure them all, take it all back apart, and do it repeatedly until you get them all sorted back to where they need to go.
Right.
So it's a huge time suck, right?
Yes, it is. And so, kind of skipping ahead here, another one of our things is called lean in manufacturing and lean assembly. You're no longer lean in that thing because you've taken this organized thing that was very efficient and you dumped it in a box.
Yep.
And now you have to reorganize all of that and you lost all of your efficiency.
Okay.
So everything you're doing to reorganize it is non-value added time. You're just wasting time.
Yeah.
Where if you'd have left it organized, you would have done it from the beginning. Like my always thing that I hate is this giant bolt bin of spare bolts that we have.
Yeah.
And it's like, I need a M8 by 40 millimeter. And it's like, I get my scooper and I start scooping through this mound of bolts trying to find this one bolt.
Yep.
And so you may be there for 1 minute if you're lucky or 10 minutes if you're unlucky.
Yeah. And so the solution to that, well, I guess the lean part of that, this wouldn't be Pokeyoke, but lean would be to buy the like Fastenal thing with every nut and bolt size you could think of that you use.
Or at least it's labeled. So when you're taking it apart, like we do with our engines, we put them in those compartments. You know, these are the cam cap bolts, and these are the front cover bolts, and these are the clutch bolts. You know, they're all organized in those bins that we have when we disassemble an engine.
Okay, so how do you identify when you should be airproofing something? Like when should you Pokeyoke something?
I think it's when it's important.
Okay,
like whenever you are either designing this thing or you are trying to keep the efficiency high, or it's prone to, if you don't assemble it in the right way, you're going to hurt something. Another example is like the Evo 8 front cover. Every single bolt is specific. Not every single one, but almost all of them, they're specific.
Yeah.
So you take them out, and you have to go back in the same hole.
Yeah.
And so that is, Mitsubishi did not aeroproof that or Pokeyoke that.
Okay.
Because you can put any bolt in any hole, but it's now not going to perform correctly because it's going to fall out, it's going to break a tab, it's going to be too long, and now it won't torque down.
Okay.
It's always going to be something when you put together.
But the Evo 10 one is only 2 bolt sizes.
Yes.
And they're identical in the respective size.
And they Pokeyoked it because there's only one way it can go together.
Okay. Interesting. Okay.
Yeah.
Okay, so for a smaller shop, like when you're manufacturing a part, should you be designing in these Pokeyoke things so your end users can know, like, when I buy an ETS intake as an example for an Evo 8, you know, it's not a very long pipe, but it's got like a small bend on it and then a straight. But I see people all the time putting that in backwards. Now, like, it doesn't really necessarily affect the performance, but you can tell when it's installed incorrectly. Is that something they should be looking to Pokeyoke or like label, like intake side, filter side? Is there different? What's the best way to handle that?
Yeah, so I think that's like a multi-part question. So the first thing is, in this case, it's probably mostly aesthetics. Like you said, it does not hurt the performance. It's not going to rub on the radiator and rub a hole in it, or it's going to hit the engine and wear out a wire or something. You know, it's just, it fits a little funny. And so if I was manufacturing this piece, I would label it, or I would designate, you know, make it to where like one of the little bungs or one of the bosses is on one side. And, you know, if it's on the far side, then it's closer to just a filter. The other side goes to the turbo.
Okay.
Or whatever.
Okay.
So I think a lot of it is the user experience. So if you're selling a component that is retail and you're expecting your customer base to install this and they receive it, and it's like, I'm putting it together and I spent, as a novice, like a shade tree mechanic or whatever, it's like it took me an hour to put this thing together.
Yeah.
And I put it on the car, and now it's backwards.
Okay.
I got to take it back off the car, disassemble it, reassemble it, and then put it back on. Well, it took you 4 hours to do this whole thing as opposed to 1 hour or 2 hours the first time.
Sure.
So then they go on to your review page and like, well, this sucks because I spent all this time because it goes together 3 different ways, you know. And so if you'd have designed that in a fashion to where it only goes together one, the user experience is much better.
Okay.
And so it may fit right the first time, or it may perform better, because of the orientation of it. We see all the time with blow-off valves that are in backwards.
Yes.
And then it will not perform. It has like no boost because it won't actually build.
Or flutters real hard.
Yeah, right. And then you flip it over and voila, it works perfectly.
Yep.
But it's not intuitive as to, well, this is in and this is out.
Sure. And those are definitely not Pokeyoked then.
No, they are not.
Okay, so then another example of someone who's manufacturing something who should do something better. And this happens on basically every catch can we have for the Evo 8s and 9s and 10s. The hoses come disassembled with loose fittings. Mm-hmm. And there's any combination of like 45, 90 straight, like who knows what goes where. And you just kind of like mess around with it till you figure out what looks right. Like that's something they could label in a bag or something or put them on the hoses already assembled. I mean, what's the better way to do that?
And I think a lot of that is, and I'm going to go off on a tangent because I don't like this. It's the same thing, but it's the freaking oil coolers.
Yes. Oh, yeah.
Where they have this stainless lined hoses. And if you're not familiar with how it all goes together, it hurts.
Yeah.
Or you have to push really hard, or you need a particular tool to do it correctly. And so if they would have put one end on it, and then made the other end either a little long or loose, and then you just torque it down at the end or whatever, then 50% of the work is done. This hose is the upper hose, and this hose is the lower hose because of the way that the fittings are on there.
Okay.
So I think instead of, in this case, they did it because they were trying to save money because they don't want to assemble it themselves because they know it's not fun to do it.
Yeah.
And they're making the customer do it, but it's a bad customer experience because of that.
Yeah, and I guess Lance has the power steering hoses. He leaves most of them are fully assembled, but one of them is not, and he said it's because every car can be different lengths between where the reservoir is and the pump, because some of them have been in an accident or some people move the reservoir over. So, like, how much give should you give for like variations in car to make that fit? Right. And so how far do you want to go, or what's the furthest away that it potentially could be, and then you may have the other thing. Or I cut it too short. It's a bunch of crap. Yeah, or it's really close, and now your hose is bending around and rubbing on stuff. Right. Or it's kinked. Okay, so there's some give and take on how to design a part there, but I really do like the idea of assembling it with one hose. That's probably a great idea. Yeah. Especially if you have 4 hoses and 2 of them are the same, you can leave the same ones, the ones that are not attached. And the variations are clearly on 2 separate hoses. Right. So you can figure that out. Right. Easily. Or you've clearly labeled it. Like you put a paper label around it. Okay. This is power steering pump. This is valve cover. This is, depending on what your situation is. Sure. It's a breakaway thing. The customer can take it off because they don't want to leave it on there forever. But you've told them an indication of this is the way you assemble it to give you the highest performance that I can give you as a manufacturer. So you get the IKEA instructions. You just take a single picture of your assembly, and then you put a colored dot where the hoses go or the hose clamps go. Right. And then you put the same matching colored dot on your actual hose on your printout or your PDF or whatever. So you just look at the picture. Red goes here, blue goes here, green goes here. Okay. So there's different ways of handling it. Nobody does anything, but no. Clearly my favorite is when they're already assembled. But yeah, just put it in and we go. Yeah. Okay, so let's move on. The next one is Kanban or Kanban, however people want to say it. I always say Kanban. Go ahead and explain what this is, maybe how you would use it in manufacturing, and like what the idea is behind it. All right, so the OG or the original way that people did it was with paper or cards. So the example that we always use is you've got a bin of, say, seals in your engine assembly, and whenever you get to your order point, that's where you put your card in your bin. So say that I have 10 on the shelf, and when I hit 3, that's my reorder point. So you put the card on seal number 7. And so when you get past 7 seals, you take that card and you run up to the person ordering and say, hey, I need another batch because I've only got 3 left at this point. And so I need to replenish this stock. Okay. So that was the original way that you do it. And of course, everyone's on electronic now. Right. In MSA, we have a feature that does this through some scanning of codes through your phone or through your scanning device, your barcode scanner. But in more modern manufacturing, it's some sort of code. It's some sort of automated replenishment. It may send a message to the person in the front, or come up with a pop-up, or automatically add it to a PO. That way they know they need to place the order through the system or whatever. So reorder points automatically reordering whatever product or supplier piece you need then, right? Right. So the Kanban is
a correlation of this physically. So you're giving it the notice of when you need to replenish your stock.
Okay. And then how does it keep from like overstock? Is that something that would help at all, or is it just kind of something you just have to learn through by like how much you're selling over time?
I think that's a part of it because, you know, on our seal example, if you know that those 3 seals are still going to take you 6 weeks to go through it, well, maybe your reorder point's too high. You know, if I can get those seals in 2 days, I can put it in 1 or 2.
Sure.
You know,
but if it's coming from Netherlands, like Chris had a problem where if it's coming from the Netherlands and it could be 3 days, but it could be 2 months, then it's much a better idea to have a higher stocking inventory, right? I guess. Okay.
Right.
So how does like a manufacturer use Kanban for like manufacturing flow, not just like inventory? Okay.
So what I've seen in the past is basically every job or every in MSA we have the zones, and so each of the jobs are in a zone. So say at a large manufacturer, you've got, you know, maybe you're putting the tires on the car or you're putting the hood on the car or whatever. When the car gets to that point, the system either has some automated way to move it between your different zones, or it's got a manual way to move it. In our case, it's manual. So either you do it through a scan or you do it through a manual click, and you move it between zones. So you always know where in your process that your job is.
Okay.
So in MSA, or like when we do it with our shop, you say you're doing a full engine build, and whenever you pull the engine out, it moves into engine build zone.
Yeah.
And then as you move through, now I've torn it apart, or now I'm at the machine shop, it's in the machine shop zone, it's in the reassembly zone. And so as you progress based on the zone, you know where it is in your workflow at all times, to where you can balance your workforce, or if you've got too many in one whip or one zone, it's like, I got a whole bunch I need to disassemble. So I need to get that tech and that tech, and you guys are disassembling all day because this zone is completely full.
Okay.
Because for whatever reason, it's loaded up to that point.
Sure. And we did, or I've tested this with recently with our e-commerce department inside of MSA. So we have zones for when an order's taken in, then if it's an OPP order, so we're like drop shipping it from someone else, or if it's a manufacturing order where we're making the part, or if it's just something we have on the shelf and we just put it in a box and ready to ship. So we have 4 different zones there, and I just kind of drag them along and move them into the zone I want. But now you made me think of this. This is like the next tier of this is like when you go to Discount Tire or something like that, where they're just texting you every time it moves through the steps, right? So it'll be like, hey, we're ready for your appointment, and you drop your car off, and then it's like, we have started on your job, and you get a little text message, or your tires are now done and installed. You can come pick up your car, and they just send it. So that's like, I guess, like an automated Kanban, like customer interaction, I guess, because they're doing it on their end, right? Is kind of how it is.
Yeah, exactly. And I've seen dealerships do something like that, and they've attached pictures to it.
Sure.
So it's like your vehicle is now in the tire balancing zone, or you're now doing the oil change, and you had a leak right here.
Yeah.
Or I noticed you had some damage, and it's all, and every time they move the zones, they'll message you and say, hey, here's some information about where you are in your workflow.
Okay. And so at least for Discount Tire and a dealership, they're very much repeated processes. Discount Tire especially. Like every car is getting tires and maybe a couple add-ons, but that's basically all of them. So the process is super repeatable. How does this work for like a one-off? Like, if you want to make a custom manifold, or a car is coming in for, a custom build, like how can you use that to do that kind of work?
I think it really is the same thing. Whenever you're receiving in your work, so you're a service writer, or say you're a one-man gig, and you know the steps, I have to pull the manifold off, the original one, and I have to create a jig, and then I have to cut the pipes. You know what the steps already are because you've done it maybe on a different type of car.
Okay.
Or if you have no idea what you're doing, like in the restoration shop, you just know I'm in body.
Okay.
Or I'm in engine.
Sure.
But I have no idea the scope of work because I haven't torn it apart yet. So I don't know how many individual steps that I need.
Sure. Okay.
This also helps you quote your work, to where if you know exactly what all your steps are, you can understand if you're charging correctly for when you're estimating to the customer.
Yeah.
Because like I have a clutch, and there's 3 steps to a clutch. Make sure you capture all those steps when you're estimating for the customer.
Okay, so we do that really well. Our shop has done. We've evolved this over time, right? So it used to be engine build, and it was just one line on an invoice, and we would just take the engine out of the car, disassemble it, reassemble it. Yeah, labor. Lots of shops do labor. That's the worst way to do it, of course. But over the years, we've evolved it to be like we have one step is remove engine, one step is disassemble engine, one step is to machine the block, one step is to reassemble the block, one step is to reassemble the long block, and one step to install long blocks. So it's like 6 steps to do an engine build, but it allows us to capture the labor at each step. And now we can also handle variation too, because if somebody brings us a car with no engine in it, we just start halfway through. Right. So it's like just all we're doing is like machining, assembling, putting it in the car. Or maybe they're just bringing us a long block, so we just remove it. We don't have to disassemble it. We just take the other one and put it in. So you're skipping steps, but it gives you some variation on your Kanban flow, I guess, right? Being able to do that. But the smaller the project, the more time-consuming that gets, I would guess, right? There's kind of a give and take on how broken down you want to make it.
Definitely a point of diminishing returns on that. So, the further down the rabbit hole you get, the less amount of profit, because you're over there tediously writing every single thing down to make sure you've captured every single minute.
Sure.
And, in MSA, it's more forgiving. You could do it either way. If you want to have one giant timer that does all your stuff, then you can capture it that way. But if you want more of a detailed timers, then you can track that over time, and you can kind of get an average of how good you are at that particular task.
Okay, so let's move on to the, I think this is basically the last one here, but lean manufacturing. What is lean manufacturing? I've heard that said a million times, and I still don't know what it is.
Well, lean is a whole thing. So the lean conversation is depending on your point of view, depending on your philosophy, depending on what kind of business you have. I mean, there's a million different ways to define lean, but lean is basically a way to capture your efficiency or trying to make yourself be more efficient.
Okay.
The first step at lean is kind of what we always kind of start with, which is trying to figure out how inefficient that you are.
Okay.
And that's either through running a timer on a job or like looking at your workstation layout, and every single time I have to get my wrench, I've got to step over here, go around the corner, grab my wrench, go over here.
What did you call that? Spaghetti diagrams?
It's a spaghetti diagram because it's tracing your steps for each process. And so once you kind of understand how inefficient you are, then you can start to look at how to make yourself more efficient. So, with the timers, that's kind of intuitive. And it's like, well, I took those bolts out backwards, or I did the wrong order, or I didn't follow the service manual because I thought I knew better than it did, or with your spaghetti diagram, you redesign your workstation to where the tools you need the most are most accessible, and the tools you don't ever use, like say you work on an import car and every single tool is standard or metric. Get rid of the standard tools out of your box. You're not going to use them. Put them in your box that's on the wall or whatever, and then it's not going to get in your way to slow you down to fumble around to look for your other tools. So it's ways of finding efficiency in your process or in your business.
Okay, and then another way of efficiency, and this is like I think the more common thing that I've heard from lean, is to reduce waste. Can you kind of walk us through that?
Yeah, so waste is a whole other conversation. So waste could be wasted labor. It could be physical waste, like you're putting parts on 2 or 3 times, or maybe you're flushing stuff a little too much, or say you've got an ultrasonic cleaner and you're changing all the fluid between every single engine. Maybe that's not necessary. Maybe there's other ways to lessen your waste.
Okay.
Like with the ultrasonic example, maybe you put a filter on it and you filter out the little particles.
Okay.
And now I just service the filter, once every engine or every other engine, depending on what it has. And you don't have to spend $100 and an hour and a half or whatever of time. In our case, we use RO water, and so it takes overnight to flush it out.
Yeah, a day to refill it, right?
Exactly.
So the machine is down while you're trying to clean the machine for more than a day usually. So okay. And then what wastes are the most common? Like, is it time waste or is it like, I would think if you're manufacturing 1 million parts, the problem is not necessarily time. It's like bad parts. Is it like bad designs or like machines are not very good or you run on material and half of them are like missing stuff, right?
Well, it's all of that.
Okay.
Every single thing you said. So you could have a part that was scrapped, like you received a part from your supplier and it's got a giant scratch on it, or you received a turbo and it's missing a vein or something. You received it in and it's junk, but you didn't know until you started putting it together because you didn't open every single box to check every single thing.
Right.
And that's not. And it's waste in two ways because now you've wasted the part, but now you got to waste a bunch of time calling the manufacturer, making an RMA. I got to swap this part out. Excuse me. And now it takes you another week or two, and the car's off in the back because you've wasted all this time. So that's like a physical waste. The other stuff that you can do is, you're filling the oil for the first time after an engine build, and you forgot to put the drain plug in, and now the oil's on the ground. You literally wasted all that fluid that's come out because you're not going to reuse that to hit the ground. Sure. So, there's many different ways of waste, but in our MSA business, we see people wasting a lot of time.
Yeah.
And so
Tons
there's
of it.
tons of time. And so when you go through the formula to figure out your shop efficiency and you're in the single digits, you're still positive, which is good. But there's a lot of wasted time. And so we always try to coach you or to tell you or show you different ways to be more efficient with that so you're not wasting all that.
Okay, so I have a great example that I just thought of. So Pokeyoke, Injector Dynamics, he had a good video not too long ago about how they assemble all the injectors. And one of the things he does, and I was kind of surprised by this, is they basically test every single injector. So, I mean, the end result is that customers are overwhelmingly happy and probably super, super low, like, I guess dead on DOA, dead on arrival sort of problem. But he spends a lot of time doing that. So is that lean in the fact that it's very, very labor intensive? Or could he relax some of the testing and accept failures on the customer end? It's got to be. He's clearly defined 0 problems to the customer as the goal, right? So that's kind of like his lean goal is customers, no problems. We'll eat the extra time on our end, right? So there's probably a formula for calculating this, right?
Yeah, and I think the formula is based on your philosophy. Like I said at the very beginning of the lean conversation, it's really based on your philosophy, and it's based on not necessarily the right or the wrong way to do it. It's based on how you want to run your business. So in the Injector Dynamics example, his philosophy is, I want 100% quality. I do not want a single customer to open up a brand new injector and have a failure, or it's not going to perform 100%.
Sure.
So he has built his reputation on very high quality, but he can demand the price because of that.
Sure.
There's some other injector manufacturers where they're much more cost effective, but you have a lot of those failures, or there's not an O-ring in there, or the connector's a little damaged, or the pin is bent. The quality control is lower, but they don't have the reputation that ID has for 100% all the time, and they're going to perform no matter what.
Okay, so having the reputation also dictates the pricing of the product, then, is what you're implying.
Right.
Okay.
Right.
Okay, so give us a real lean example we could do at our shop. What's something that if you had a chance to do here, what would you do next?
In our case, I think that we would make our techs more efficient. We have a new tech. He's learning. Yep. It's been a challenge for him to pick up all these skills. He's got a different skill set for how the Evo world works and how the Evo car physically works. Okay. So I think once he gets a little bit more efficient, then we can say that we're running more lean. Like when you've got 2 guys doing it for 15 years and you show, I look at a bolt and I say, oh, that goes in the transfer case, and it is it needs this socket with this extension, and you know exactly how to put it in.
Right.
Till you get that kind of muscle memory to where you see that bolt, you automatically trigger the tools it takes to put that bolt in. That's when you're now as efficient as you possibly can be. So whenever you get your employees to the point that where they're 50% efficient or 60% efficient, you know, you're starting to hit your lean legs.
Okay.
And you're starting to say, yeah, I'm lean now, because now in the time it took me to do 1 clutch, my tech can now do 3 clutches.
Okay.
And so now I'm making even more profit because I could turn it over faster.
Okay. And so then reducing some of that time waste, the other things we talked about, like shadow boards, standard work, like telling him how to do what we're going to be doing. You know, shadow boards, here's the tools you need to do the project. Like all this stuff kind of like compounds into making the process more lean by reducing that time waste, you're saying.
Right. And then if you use the Kanban system in MSA, he doesn't have to waste time, or your techs don't have to waste time to figure out what to do. They don't come in the morning and go, now what car was I working on and what do I need to do? You look at your Kanban. I am the engine guy. Here's my list. I know what order I need to work on today.
Okay.
So like you said, the shadow boards, the spaghetti diagrams, workstation layout, your Kanban system, making sure your product has been Pokeyoked, all these things roll up into lean.
Okay. And so like, can a small 2-person shop implement this stuff? Is this doable? Like, can they say they are lean by implementing this stuff, or is it kind of a waste of time?
I think so, because if you look at us 10 years ago, were we lean?
No.
No, we were wasteful.
Yeah.
Not only with physical parts, we're wasteful with our labor. We're wasteful with customers' time. You know, it was a lot of things that we learned by the school of hard knocks. You know, it's like, or feedback from your customers, and the customer's like, hey man, it took me a long time to get my car, or, you know, you got a lot of whip. There's a lot of cars parked out here. I didn't have a single place to park my car, you know, and it's like trying to manage all this stuff is where you become a successful business. And that's really the difference between a successful business and an unsuccessful business. We got lucky in a lot of ways to be successful, because there's quite a bit of luck in that. But I think that the ones that figure it out earlier are more successful.
Oh, for sure.
You look at some of our other friends in the business, and they started about the same time we did, and they're way further ahead, you know, because they figured things out in their space or in their business before other people did.
And it's kind of why I like this podcast, is because we can teach people that are getting started or have been going and are stuck. Like, why are you stuck and how do you fix it? And like, these are solutions that, like, while we may not be the best at implementing them, you have done to the extreme at your day job of this stuff, right?
Yes.
Like the manufacturing stuff at that level, it's down to the like minute detail,
or
right?
second.
Okay. Okay, so let's move on to the last topic here. We'll just touch on this one a little bit. So just-in-time manufacturing. This probably everybody's heard of this before, because it's really like pioneered by Toyota, right? The concept is that if you want to build something, you don't have a giant warehouse with 10 million parts to assemble that part. You just kind of order what you need right before you need to do it. Is that kind of the idea?
That's the idea, basically. So the idea is having a warehouse is waste.
Okay.
Or
more lean.
It's not lean.
Not
if you have a giant warehouse you're pulling from, it is not lean, because either you had a bunch of money tied up in inventory, or you've got inventory that will not turn over. Maybe you ordered too much and you didn't really look at your market properly, and you're like, oh man, I shouldn't order 10,000 of that washer because I've only sold like 500 of them, you know?
Yeah.
And so it's waste. And so just in time is to try to get rid of all that. So it forces you as either an owner or as the person that orders all the parts in your business. It forces you to look closer at your flows to understand how to not be wasteful. Now, I'm not saying don't buy in bulk. I'm not saying don't stock parts. I'm saying be smart and strategic about what you're doing. And so for us, I'm not going to stock 4 turbo kits for the same car because one, there's a lot of variation because people want their own color, their own bend, or their own
this
special
turbo,
little,
that turbo, this
exactly,
intake, right?
exactly. On that, this turbo requires that oil line and that coolant line or that intake because now it's got a funny elbow on it or something. So for us, we order based on when the car's going to arrive, or we have insight from our suppliers about how much is in stock. Like we can look at our suppliers and go, okay, well, they've got 10 of that gauge on the shelf and this car is another 2 months on my engine build. I don't have to order it today.
Yeah.
Because it'll just sit there and collect dirt for that. And now I'm carrying that inventory against my bottom line, and okay. I can order it later. So for large manufacturers, a warehouse is wasted space because you've got people with driving forklifts or doing some sort of material delivery, and they're having to search the warehouse for the part. They go retrieve it, and then they go take it to the work center or the assembly line or whatever you're doing. If it's just in time, the guy pulls it off the delivery, like off the trailer, and takes it straight to the line.
Okay.
And he's not wasting his time to go put it here and then
go get it
crap,
later.
I got to move it over here because now that bot's full, and now I got to take it to the line. And where was it? Oh yeah, we moved it over there.
Okay.
So it saves it's making your spaghetti diagram be a one piece instead of this scattered mess.
Oh, interesting. Okay. And then, so there's advantages to this. So we do it mostly because we don't have to have $1 million of inventory on the shelf. And the only way we'd sell stuff is by installing it. Mm-hmm. Now that we have a web store, we can move stuff a little faster that we're not installing. So that kind of invites, buying more in bulk and kind of like using that as like, a way to make a little more margin. Mm-hmm. But how does that save on shipping if you're buying it only when you need it, right? It's actually more expensive. Is that?
Yeah, if you have multiple shipments, that is for sure true. But if you know that you've got a big build coming up and you order 50% of your parts from one supplier, you know when that engine is about to be built, and so you can just order all those parts, and then you bundle all the shipping in one, and then you ship it out. Or maybe there's 2 engines you got back to back that as soon as I do this one, 2 days later, I'm doing that one.
Okay.
So all these parts can arrive at once. You assemble your thing, you put it in a car, and you're in business.
Okay. And then on the manufacturing side of things, it's really about how many your dealers want to stock or how much they're selling. So then you're not using like what I have in the pipeline. You're going off of like a metric of like, how often do we cycle this per year, or like what is the turnover rate? Is that kind of the idea?
Right. And then a lot of companies will use their dealers as their inventory or as their warehouse.
Okay.
It's like I've sold 5 of my dealers all these gauges, and I know that because I don't have to have as many on hand because I'm making the dealers be the stock.
Okay.
And I'm not having to stock everything myself.
That's how manufacturers do with vehicles, right?
Yeah.
Like Ford or Chevy or...
Yeah, as soon as it's built, it's out of here, man.
Okay.
It's headed to the dealer or headed to some lot in order to be staged to sent to the dealer.
And let them sit on the inventory.
Yeah, because you don't want to sit on inventory because depending on how big of an operation you are, you're paying taxes on that.
Uh-huh.
For us, we don't pay a lot of taxes because we don't have a lot of inventory. But if we had $10 million worth of inventory, you're paying taxes on that.
Sure.
So it behooves you to not have that inventory, not only from an efficiency standpoint, but from a tax standpoint.
Interesting. So then, but the downfall is when you have low stock and you do suddenly have a run on it or can't get more of the supplies.
Right.
Now you're out of stock and can't sell them, right?
Or your supplier says, screw you guys, I'm not going to make that for 6 months because I'm not tooled for it. You're screwed.
Yep.
So you have to be, it's a dance.
Okay. Okay, well, that really covers it. I think we kind of went over all the primary topics of kind of manufacturing. I would like anybody who has any questions to send them to us, and me and Richard can answer them before any podcast. So if we miss something or you want us to cover more of something, just let us know, and we can go into it. And also we can invite other guests that might have more insight into some of these topics. So thanks for watching the 2-part manufacturing series, and thanks, Richard, for sharing your information or your knowledge with us.
Of course.
Okay, thanks.
Thank you.